look at a situation here where we have a mass, 90 degrees Celsius mass placed into 10-degree water, and we want to find the overall change in entropy. So if we consider that, right, this mass is going in there, we know that this mass is going to cool down, and therefore the order is going to be more, right? But again, when we're considering the entire system, we have to consider everything, right? And what's the change in entropy of everything. So, what we're going to have to do first is figure out, what's going on with the temperature, right? Here's the mass, 1.24 kilograms. Specific heat of the copper is 390 joules per kilogram degrees Celsius. Initial temperature is 90 degrees. We have the water here, which is 0.73 kilograms and 10 degrees Celsius. So we know that we're going to need the average temperature eventually, right, to be able to look at entropy. So the first thing we got to do is calorimetry. So go ahead and pause the clip and figure out what the final temperature would be, and then we'll move to the entropy part. All right, so sum of the Q's equals 0. We've got those, and so we should get a final temperature of 20.931 degrees Celsius. Now that we know the final temperature, we can look at the entropy change for both the copper and the water. We're going to do both here. So once you see if you can do that, go ahead and pause the clip and try this here. And when you're ready to check, you can hit play to continue. All right, so we'll use this one for copper. We'll use this one for water. And we have MC delta T. We know the mass of it. We know the specific heat. And we know the difference in temperature, final minus initial. And we'll end up getting a change of negative 101.69 joules per Kelvin. For the water over here, we have 0.73 times 4186. We have the final temperature minus the initial temperature, and that's over the average temperature, which we have there. And so we get 115.795. So when we bring those together and we add those together, we get an entropy change of 14.1, right? So this means that even though, this became more ordered, right, negative 101, this became more disordered and more than this, right? And so the overall entropy change is positive, and that's going to be true for any natural process. So, you can have a decrease in entropy from one part, but, in that other part, it's going to, compensate and be a greater entropy change.